Good morning, everybody. Let us quickly discuss. Any doubts are there? Question number 19 will be discussed by Ashish sir later. Question number 21. Any doubts are there? No
Yes, sir.
doubt.
Can you once explain?
21. Okay. So in 21, so solution of Na2CO3 is titrated with HCl. That means basically you are titrating CO3 2 negative with H plus ion. And using phenolphthalein as an indicator and methyl orange as an indicator. First, you have using phenolphthalein as an indicator. So when you're titrating it, you are getting HCO3 negative and plus H2O. This is called phenolphthalein endpoint. That means at this point, phenolphthalein will change color and you will stop the titration. So is this at this point, you can say CO3 2 negative is completely converted into HCO3 minus. This is the point where pH becomes what we already know. At this point, pH is given by half pK1 plus pK2. Or you can say H plus concentration is equals to under root of Ka1 into K2. So if you have to convert pK, if pK is not given, you can calculate the H plus ion and then you can calculate the pH. So what is K1 and K2? 2 into 10 to the power minus 6, right? Into what? 4 into 10 to the power minus 10. You take under root of this, which is coming out to be 8 into 10 to the power minus 16 and the root of this, which is equal to 4 into 10 to the power minus 8. That is H plus ion concentration. So pH will be equal to what? Minus log of H plus ion concentration will be equal to what? 8 minus log 4. Just keep it here. That's called pH1. I'm not going to simplify log 4. Maybe that term can also be used. This is the first point. At phenolphthalein endpoint, the pH will be 8 minus log 4. Log 4, we already know nearly it is 0.6. So it is 7.4 nearly. Now you're further titrating it. And it is taking one more H plus ion and it getting converted into H2CO3. This is called methyl orange endpoint. At this point, what will happen? HCO3 minus will be totally converted into H2CO3. So how much H2CO3 you will get? Here, concentration is required. Be alert. Here, concentration is required. The problem is based on this fact that here concentration is required. So read the question carefully. It is 0.1 m and 0.1 m. So when you titrate 0.1 m and 0.1 m, so you will of course have to use the volume equal to what? V and 2V. V and 2V total is equals to volume is equals to 3V. That slight mistake you may made. Okay? Understand what I'm saying? आगे बढ़ो, समझ में आ रहा है?
Yes, sir.
3V volume is important. Here you can do a mistake that the concentration at this level will be 0.1 divided by 3, not 2. Few students might have done this mistake. Okay? So if that is the thing, 0.1 minus 3, now you have to calculate what is H plus ion concentration. This is polybasic case. H2CO3 will dissociate into H plus HCO3 minus. Second ionization you need not take because first ionization H plus ion will be more than sufficient. You need not take the second ionization. Simply write here H2CO3 is equal to 0.1 by 3. Take it minus x and x. Ignore x. Ignoring x, you can get x square upon 0.1 by 3 is equal to 2 into 10 to the power minus 6. So that means x square is equals to 2 into 10 to the power minus 5. Sorry, 0.1 you have multiplied, na? So that is 2 into 10 to the power, guide me, minus 7 divided by 3. That is the situation. So x is equal to, we will write it, just divided by 10 and multiplied by 10. So this is 20 by 3 into 10 to the power minus 8. I would like to put it like this. So pH will be, this pH2 will be 8 minus log of 20 by 3. So that will be the difference.
So it is x square, not x. Last second line.
Last step, yeah, you're right. Sorry. So in the last step, what we need to do, x square, so we have to take under root of this also. Sorry, 20 by 3 root of this into 10 to the power minus 4. So the pH will be 4 minus log of, that means half log 20 by 3. Half log 20 by 3. You understand what I'm saying?
Yes, sir.
So now you can see answer is coming or not, I don't know, because I have not fully solved it. You asked it, then I solved. I hope that answer must be matching. Mistake to nahi hai? You're getting the
आंसर मैच नहीं कर रहा
nahi kar raha, to just
ठीक
report it to the authorities. I think that the reason why the answer is not matching is that in titration 0.1 m Na2CO3, they might have taken, they have also might have taken the two factor, they might have taken the factor of 2, nothing else. Okay. Sometimes this happens. If answer is not matching, please ask the authorities to change it. Done. Question number 21. Next is, this question is question number 22. Might have done easy question, but I'll discuss the shortcut method of these problems. I think you also have used the shortcut, but still I'll discuss it. So in this question, as soon as you see, first of all, the temperature is not given. So you have to assume that this is at the boiling point. Boiling point means what? 373 Kelvin. And at 373 Kelvin, vapor pressure is equals to 1 atm. And you also have to assume 1 atm is equals to 760 mm of Hg. This is the supposition you have to take in the problem without thinking. Now, elevation and boiling point is given, which is delta TB. Delta TB is equals to Kb into M. So you simply calculate M. M is equals to delta TB upon Km, Kb. Now at this point, once you get the M and they're asking you the depression, relative lowering in vapor pressure, use the formula P0 minus PS divided by PS is equals to NB upon NA. This is the exact formula. And my advice is to use this because people don't take this. I hope that you're understanding. This is a very late time. My advice is always use this. Now, NB upon NA can be written as NB is the number of moles of solute here. B stands for solute and A stands for solvent. A stands for solvent. So NB you should multiply it by MA dash. And Na should also be multiplied by Ma dash. See what is Ma dash? Ma dash is equals to molecular weight of solvent in kg per mole. Not grams per mole, kg per mole. For example, water, Ma is equals to, if A is the solid water, it is 18 gram per mole. That's the molecular mass. But here, Ma dash is equals to what? 0.018 grams, kg per mole. So idea is this, that then this NB upon Na will become what? If we have ample practice, that will become, you can clearly see this quantity divided by this quantity will be what? The molarity, small m into Ma dash. So you simply get small m into Ma dash, then 760 minus the vapor pressure which has been lowered upon P is equals to this small m into Ma dash. And we will put instead of this small m what? Delta TB upon Kb into 18 into 10 to the power minus 3 and calculate this expression. So that becomes 760 by P minus 1 is equals to delta TB upon Kb into 18 into 10 to the power minus 3. I will always prefer this method. More exact than getting the answer. So see to it that you are getting the answer or not. What method solution is given, I don't know, but I will try to solve the problem. Always try to solve this slide. Next question is question number 26. Is there any doubt? What has been done? Any doubts here? In a constant pressure calorimeter with heat capacity of this 200 ml of 0.862 m HCl and 200 ml of 0.43 m B, which was mixed density is this. Initially, both solutions are 20.4 degree, 48 degrees centigrade. Select statement. I think that in this question, you have to take some assumptions. What the assumptions are there? Heat capacity of all other things you have to ignore. You have to also find that solutions heat capacity is equals to solutions heat capacity is the solvent heat capacity. So you have to use the heat capacity of water, which is 4.2 joules per gram per degree centigrade. You have to use this. So 200 ml and 200 ml are mixed together. So total is 400 ml. This is the heat capacity may be used, and one data is not given. And that data needs also to be used also. So this question is, if data is not given, this is an incomplete question, because you need to know delta H neutralization is equals to minus 57.3 kilojoules per equivalent. So that data you have to use. You can, of course, object on this question as well. That said, data is not given, but I hope that most of you have remembered this data. Is that the case?
Yes, sir.
Yeah, you can always ask. The data should have been given. If data is not given, how can you do this? Should I discuss it, or it will be done? Done?
Yes, sir. In the delta H naught, doesn't it mean 1 mole each component?
Delta H naught. No. Delta H naught means only standard. In fact, that is another issue. Delta H should always be given. Never rely on any data, because delta H is an extensive property. Okay. So when a reaction is there, suppose H plus plus OH minus is changing into H2O. So you are writing delta H of this. That means delta H of this is called joules per unit extent of reaction. Okay. So never rely on this one till an equation is given. If you write twice H plus plus twice OH negative, that means it is twice H2O. So remember one thing, for any chemical reaction, whatever is written, take it as it is. That is for the delta H. This is a very important thing. In a very late time, you are asking this question, and I have very less time to explain you. Their students are always confused. So I think that very quickly I will take time, because this is one fact which you could not ignore. Let me tell you. 2 moles of A plus 3 moles of B is changing into 4 moles of C plus 5 moles of D. Suppose one situation is there. And written delta H is equals to 20 joules or kilojoules per mole. What do you mean by mole? Mole of what? Mole of what? Mole per unit extent of reaction. What is that? This is minus 2 dx. If it is minus 2 dx, it is minus 3 dx, it is 4 dx, and it is 5 dx. So theoretically speaking, delta H should be written like this. Suppose at this particular instance, because H is a state function, its value also depends on what state of concentration something is there. Suppose is this particular time enthalpies per mole value is HA, per mole value is HB, per mole value is HC, per mole value is HD. Then the net change in enthalpy becomes what? It becomes what? HA times 2 times of dx, negative sign, minus HB times 3 times of dx with negative sign, plus 4 times of HC, 4 times of HC multiplied by 4 times of dx, plus HD 5 times of dx. That should be the total grand change in enthalpy. Try to see this. Okay. So this means this total change in enthalpy due to this chemical reaction, which has progressed only by dx amount, which is called extent of reaction, is equals to, see it carefully, take dx common. If you take dx common, this will becomes minus 2 times of HA, minus 3 times of HB, plus 4 times of HC, plus 5 times of HD. and this quantity is called delta RH. This quantity is called delta RH. See it carefully. So you can say that delta RH is equals to dH upon dx. It is just like velocity. Velocity is equals to meters per second. That only tells something like, that something is moving this many meters per second. Okay, that doesn't literally means that in 1 meter that thing will move, because that's an instantaneous velocity. Similarly, these enthalpies are also given like instantaneous value, that at that particular time when enthalpy will change. What is this? This is total change in enthalpy, and this is what extent of reaction. So at this late hour, I can only tell you this one. This example I have taken you to make this point absolutely in your mind, that basically enthalpy change is what? Enthalpy per net extent of reaction. समझ आ गया क्या? Is that clear?
Yes, sir.
Yeah. So always take it the whole equation. Now, literally that means what? Use one more thing. See, if dx is equals to 1, then what is happen? If dx is equals to 1, what is the meaning? If dx is equals to 1, that means 2 mole of A will react. 2 mole of A will react, or 3 mole of B will react. Okay. Or 4 mole of C will formed, or 5 moles of D is formed. This is the idea of the extent of reaction. So it's a very beautiful concept in which enthalpies, not only enthalpy, Gibbs function, entropy, everything is presented in such a manner. So they're always presented like this one. Okay. Keep in mind. So that is it. Next question is,
So when we write delta G naught, we mean all components are at 1 molar concentration. So we don't mean the same enthalpy.
yeah, of course, we also mean in the enthalpy exactly the same. It is exactly the same situation. Okay. But
Yes,
this is slightly a deeper thing. Next class when I take, you ask me, theoretically I will clear this. Okay.
yes.
Next class I'll clear, because just make it clear. What is delta G naught? What is this extent of reaction? Slightly tricky thing. So next class I'll take time, because right now time is slipping by. I'll explain it later on. Okay. But just keep it in mind. These are very interesting quantities. Now this question is done already. 3 radial notes. It can be done. That's nothing, anything special about this. There was one more question here. Done. That Rahul sir will discuss. Then organic chemistry. Okay, pH at the half equivalence point of the titration of Zwitter ion A will align with NaNaOH and HCl. Thus the isoelectric pH is. pH at the half equivalence point of the titration is this, with NaOH and this one. So you can do this problem. You can also ask in organic chemistry. This question also belongs to an organic chemistry, but still I can discuss it, that NaBH4 will react with I minus, I2, to hydride ion will be oxidized into H2 plus twice of I negative, but one more gas is being produced, P2H6. So only thing you have to keep it in mind, these two gases are there. If these two gases are there, then total number of moles will be just double of that, and you can take it. So I don't think there any good doubt is there. This question I should discuss 33, or you will do it on your own? 33?
Will do.
Okay. Paper was relatively easy, but few questions are like this. Only totally fact-based question. I hope that you also done this question by 20, but I will not discuss this question. This question I have not got time to discuss. I think it is a mole concept, simple problem. Have you done it? Any doubts here?
No,
Detailed solution is not given, but I think easy question was there. Okay, I'll discuss this question as well. Question number 29. Entropy increases, especially this one. Surface tension decreases and osmotic pressure decreases. What is the situation? Because these questions will always be asked surface chemistry. There you use. So I will discuss this question. Many times JEE has asked this, and they'll keep on asking. What happens when you add a surfactant to water? As soon as you add a surfactant to water, situation is like this. the surfactant molecules start getting accumulated on the surface like this, and the polar heads are inside and the tails are outside. So when you start adding, and few molecules are also in the solution, situation is like this. So when you add more of surfactant, then situation will become what? The concentration, the surface will reach eventually a constant value. Okay, surface, there will be a constant value at the surface. You see, I should remove some strands here because initially less molecules are at the surface, and then subsequently more molecules are there. And the concentration in solution is steadily then increasing. And as soon as it reaches a certain value, more than certain value, it start getting micellization starts. So when micellization starts, what happened? This has on surface, they have acquired a certain constant value, and in solution, they have also acquired certain constant value. And as soon as you try to increase the concentration beyond that, you will form micelles are getting formed. That is the situation. Okay. So see what happens when you are adding soap into the water. So steadily the surface tension, if I say surface tension is steadily decreasing, steadily decreasing. Okay. But as soon as you reach this point, surface tension will have a constant value. Because then whatever soap you are adding, it is neither increasing the concentration of the solution, it is just like solubility equilibrium. If the concentration is exceeding certain value, precipitation will start taking place, and precipitation will start taking place. That means micellization is a kind of a precipitation. You can think about it. This concept is very handy. So micellization will start. So when micellization will start, the surface tension is not going to increase. That is the idea of the surface tension. Now, what about entropy? Why entropy? So entropy should increase also because of what? Mixing. When you mix two things, then you increase the options. So entropy is also based on probability, statistics, and everything. So when you mix two things, then the possibilities in which energy can be arranged in these two things also start getting increased. So that is why entropy steadily started increasing. If you add too much of anything into one, then probably entropy could decrease, because entropy of mixing is something like this. When you are mixing something, it will first increase and then it decreases. If you see entropy of mixing, if you have studied, then you might have noticed. But here we are at this situation, only up to this portion, because we're not 1:1. Soap and water could not be 1:1, because you understand what I'm saying. Soap is pretty much in limited amount, and water is pretty much in excess amount. So entropy is steadily increasing. That's a very interesting thing. You can also judge it by this, that soap is getting delta G is equals to delta H minus T delta S. Keep it in mind, the delta H of this process is positive, because soap always dissolve endothermically. So if this is positive, how this spontaneous process is going to take place? Only if the delta S is what? Positive. So these two thumb rules are there that will tell you how the entropy is increasing during this process. And when micellization will start, you will be amazed to know that entropy will even still increase. That's another thing. So when micellization take place and they becomes this, that's an amazing mind-boggling concept. Then entropy increases. The entropy of this delta S is also positive. Just keep it in mind. That's a well-established fact. And that is why you can see that craft temperature, at higher temperature, only micellization starts. So in this way, you can thermodynamically justify it. And why entropy is increasing when these molecules are getting associated together. That's a very interesting thing, because initially when this strand was there, a lot of water molecules were there, which were, surrounding this. So when these strands are coming together, these all water molecules become free, and their freedom gives rise to what? Increase in entropy. So in this way, we justify it. Just keep it in mind. Okay, so entropy of micellization is also positive, and during the process when you're adding soap into the water, also entropy steadily increases. So A option is correct. Surface tension decreases steadily, and at certain point it will stop. Osmotic pressure, of course, osmotic pressure will also increase because concentration is increasing. At CMC, that will stop, and molar conductivity decreases. No, molar conductivity was steadily increasing because concentration was increasing. So molar conductivity was also, sorry, molar conductivity you are talking about, no? Sorry, it's not conductivity, it is molar conductivity. So molar conductivity means you are adding a lot of things, but that thing is you always have to talk about the conductivity of 1 mole. So in that situation, what will happen? What about the molar conductivity?
Mobility will be less, so conductivity will decrease.
Mobility will be less. Yeah. Concentration is increasing. Yes, you're right. Since concentration is increasing, so definitely the cation and anion will affect each other. You're absolutely right. So molar conductivity will decrease. And what about miscellization? After miscellization, so definitely molar conductivity should decrease more even further, because miscellization you are adding a lot of things, but everything is getting as a micelle formation. So molar conductivity will definitely decrease. All right. So all 4 options are correct.
Does CMC depend on temperature, sir?
Yeah. Of course, it depends on temperature. But whenever you will compare, you will depend on one particular temperature. You could not conduct experiment. This experiment must be carried out at a certain constant temperature, and that temperature is above craft temperature. That is the idea.
Sure.
Yeah.
So during miscellization, osmotic pressure will decrease because of
During
association of molecules.
osmotic pressure will remain constant, na? Because miscellization is happening, but miscellization is not going to decrease the concentration in the aqueous solution. It's just like solubility product. If the concentration is exceeding certain value, then only precipitation will start. So similarly, when the concentration is exceeding some value, then critical miscellization will start. But miscellization doesn't mean that concentration in aqueous solution will decrease. That will remain constant. Whatever additional amount you are adding, all that amount is getting converted into what? Micelles. You understand?
Yes. Won't that mean still option C is wrong?
Which option?
C option, osmotic pressure should be constant.
No, they are talking in this question, what they're not talking about the miscellization. See this problem. I have discussed miscellization because maybe in the next question they are going to ask about the miscellization, because that is the most interesting thing. This
Yes.
problem is before miscellization. When you start adding soap into the water, before miscellization state has reached, what will happen? Na?
Yes.
Yeah, understood? Yes.
Yes.
Okay. So time is over, and next class I will, in my class, if there any doubts are there, spilling doubts, I will discuss over there. Okay. इसमें से कोई भी डाउट जो बचा है वो अगली क्लास में डिस्कस करेंगे. थैंक यू बच्चों.